Okay, so the section we're looking at equivalent. What does equivalent mean? If you see the word equivalent, it means that two things are equal, but they're represented in different ways, okay? So we're representing, how do we know if something's linear? We've been talking about this.
Straight line.
Yep.
It's like a straight line.
It's a straight line, okay? A straight line. So we're going to be looking at how to represent these linear relations in different ways, okay? So in this question, we're told that nuts are $30 per kilogram and raisins are $10 per kilogram. Altogether, they're spending $150 on this mixture. Okay, so they've actually given you one representation. They've represented this situation using what?
Variables.
Using an equation, actually, because there's an equal sign, right? Okay, what do you think n represents in this equation? The kilogram of nuts, and then what do you think r represents? Paula? The kilogram of raisins, okay? So all the question is asking us is to find different combinations of nuts and raisins. So for example, if I have 5 kilograms of nuts, then I can only have a certain kilogram of raisins to add up to the cost of 150, right? Yeah. So we're going to use one strategy. We're going to use a table. Okay, because this is our relationship. We're looking at in kilograms, the mass of the nuts and the mass of the raisins. We want to know if I have 1 kilogram of nuts, how many kilograms of raisins can I get? Okay, so let's start with 1. Let's choose values for nuts. If we have 1 kilogram, what would I do with that information to find out how many raisins? Yep, plug it into the equation. So again, what was the equation? It was 30, let's make this pink, n plus 10, sure, r equals 150. This was the equation given. Well, if we're saying that we have 1 kilogram of nuts, I'm going to replace n with 1. And what am I solving for? Raisins. I want to know how many raisins can we get if we have 1 kilogram of nuts. So I want you guys to solve this. What's 30 times 1?
30.
Plus 10r equals 150. How do I isolate r? Yep. No, I have to get rid of the 30 first. So I'm going to subtract 30. So 10r equals, what's 150 take away 30? 120. And how do I isolate r? Divide both sides by 10. R equals 12. Okay, so we found one combination. If they have 1 kilogram of nuts, that means we can have 12 kilograms of raisins. The total, when you plug it back into the equation, should add up to $150. Okay, let's check. What's 30 times 1? What's 10 times 12? What's 120 plus 30? It adds up. That's one possible combination. Let's just go in order. Let's pretend that they have 2 kilograms of nuts. What's another possible combination? How many kilograms of raisins can we get?
Ooh, I know the pattern.
Okay, once we plug in n, once we plug in 2 for n, raisins is 9. What did we get for 3 kilograms of nuts, Ron?
6.
And 4 kilograms of nuts?
3.
What do you notice is happening here?
Decreases by 3.
It's decreasing by 3 each time. How do you think this graph is going to look? Do you think it's going to increase or decrease?
Decrease.
Do you think it's going to be linear?
Yes.
Why is it going to be linear?
Because
Yeah.
rate of change is the same all the time.
Yeah, the rate of change is the same. It's decreasing by the same amount every time. Okay, so if we now put all this information on a graph, we were looking at mass of nuts, right? And mass of raisins. Well, what were the nuts increasing by? What was the scale I used for nuts? A scale of 1, okay? Okay, so the scale I chose for the mass of nuts is 1. What scale would be a good scale to choose for the mass of raisins, my y-axis? Okay, we can count by threes. So 3, 6, 9, 12, 15, 18, 21, 24. What was the very first combination that we went with? If nuts were 1 kilogram, what was the mass of raisins? Okay? So the first point I'm going to plot is 112. What's the second point? John? 2 kilograms of nuts gives us 9 kilograms of raisins, and so on. I'm going to keep plotting this. 3, 6, and 4, what was it? 4, 3. Okay, can we actually, because our table, we only went from 1 to 4, based on what we just discovered with the differences, I know that this decreases by 3 over 1, right? My slope is negative 3 over 1. So if I were to go up 3 and over 1, would you agree that this is also a combination? So what's the other combination I just found? 0 and that means that if we have 0 kilograms of nuts, the rest has to be raisins. 15 kilograms of raisins. What was the cost of the raisins again? 15 kilograms, and raisins were, oops, $10. Good. This works. It adds up to 150. Okay. Does anyone know what the last possible combination is on this graph at the bottom? Yep. 5, 0. Excellent. What does that mean in this question? Good. 5 kilograms of nuts. If you have all nuts, you can only get 5 kilograms because 5 kilograms times what was the cost of the nuts? Again, it adds up to 150. If you notice on your graph, we have a point here that hits the y-axis. Does anyone remember what this point is called? Y-intercept. Good. And we have a point here that hits what? The x-axis. Does anyone want to guess what that point's called? X-intercept. Good. If we find the x-intercept and the y-intercept, we can actually just plot these 2 points and then connect the dots and then look for different combinations. I'm going to show you how to do that, okay? Well, we talked about this yesterday. If you have a y-intercept, what value always has to be equal to 0? How does the coordinate start? Coordinates are read how? We read a coordinate xy. Okay. If it hits the y-axis, x has to be equal to 0, correct? If it's not 0, then it's not going to hit the y-axis. If it hits the x-axis, what part of the coordinate is 0? Y is equal to 0. So we're going to use this information. Okay, so to find the x-intercept, we know that we have to make y equal to 0, correct? And to find the y-intercept, we have to make x equal to 0. So in our equation that we were just working with, the equation was 30n plus 10r equals 150. Which variable did I have on the x-axis? N, right? We had n on our x-axis and r on the y-axis. So I need to make y equal to 0. So am I going to make n or r equal to 0? R. Okay? So we have 30n plus 10 times 0 is 150. What's 10 times 0? So that's gone. We have 30n equals 150. How do I isolate for n? Divide both sides by 30. This cancels out. N is equal to what? What's 150 divided by 30? 5. That's my x-intercept. It hits the x-axis at 5. So this time, we want to make x equal to 0. Well, remember, We had nuts on the x-axis, so I'm making that equal to 0. And I'm solving for r. So 30 times 0, 0. And I need to isolate my variable. R equals 15. Was this true? Was the y-intercept at 0, 15? Was the x-intercept at 5, 0?
Made with Doodlecast Pro.